No, don't say everything was wrong. Horizontal dilation should be f of a of x. Yeah, exactly. We know the names. All right, let's talk about this. Horizontal dilation, vertical dilation. Horizontal dilation should be f of ax. Vertical dilation should be a of f of x. Here is why. If I gave you y equals 3x plus 7 as our function. If I told you let's go and find f of negative 2x compared to find f of, negative 2 of x. F of negative 2x becomes 3 negative 2x plus 7. Can you see how the 7 didn't change? The y value actually didn't change. So that becomes negative 6x plus 7. Whereas what happens here? A vertical dilation. Well, by the time you're going to multiply your y value here by negative 2, what happens? Not only is it negative 6x, but you're actually going to get a different y value. With your horizontal dilations, because your y value is not changing, your scale factor equals 1 on a. For your vertical dilation, because both are changing, you got that? Because the whole y value is changing. So everything, the front and the first number and the second number changes when they're multiplied by negative 2. Whereas here, only the x's are changing. Your y value will never ever change. Because of that, your scale factor equals a. I'm going to save that and send that to you guys as well, as we write more notes. Horizontal and vertical stretches and dilations. Dilations. Okay, so let's go again before we do more questions. That was really bad. Yeah, question. Oh yeah, sorry. Good point. Okay, horizontal dilation has to be x-axis. So this is x-axis. A vertical dilation is through the y-axis. Okay, so let's do a question, a very basic one. So if I told you I had the point x is 2 and this is 5, 2, 5. If this became, if I shifted left 3 units and then a vertical dilation of 2 and then a horizontal dilation, because if you can understand this one then you'll understand everything. Horizontal dilation of 3. Okay, let's see what the heck has happened. So shifted left 3 units, so 1, 2, 3. Negative 1, 5. We agree with that? What's up? How come? Okay, but it starts at 2 and 5. X is 2, Y is 5. If I told you move this thing left 3 units, I hope you would have gone there. Well, you just said, I don't know what.
But that's it.
For shifted left 3 units.
Yeah,
Yeah, what are you thinking?
Parabolas.
Parabolas, you just move it, shift it 3 units to the left, that's it. Nothing else changes, you just shift it to the left. Yes? Don't ever kill it. So what's for part A, what would be your coordinate? My coordinate would be -1 and 5. We get that? Okay. A vertical dilation. Okay. What does a vertical dilation do? It should be A of f of x, A of f of x, right? This one here, vertical dilation, A of f of x, which means it changes the whole y value. Yes? By the exact same scale factor. So what's the scale factor? It is 2. So, is it changing the x values or the y values? Y values. So does x change? You just said y. So does x change? No. It's still going to be at -1. Instead of it being at 5, where's it going to go up to? 10. Because you're multiplying by 2. A vertical dilation of 2. Tiana, you think you get it?
Yeah.
What about you? What's up? Talk to us.
You said the x, it changes the y value.
Wait, the x, the y-axis. Wait. Tell me what you're thinking.
It changes the y value.
For vertical dilation, it changes the y value, correct.
Yeah, but then,
So that's why I didn't change the x value, it still stayed at -1. I multiplied the y value by 2.
okay.
Okay, so that's B. Let's write that. B is -1 and 10. And last one, there's a horizontal dilation of 3. What does a horizontal dilation do? It changes the x values. Yes? By what? By a third. Because horizontal dilations are going to be reciprocals. Does that make sense?
Yeah.
So instead of it being at -1 and 10, it's going to be at -1/3 and 10. Good girl, you actually do get it done. -1/3 and 10. That is where C is. And that would be all of these 3 transformations. A, from starting from here. From the blue one, you go to A, you go to B, you go to C. And just from that, you should see what is changing, like the x values, the y values. We'll do another one. That's it. We'll do another one. As long as you know that's a third. It's very important. We'll do another one with a function this time. Actually, I'll do the exact same, shifted, vertical, horizontal, exactly those 3 things for a function. So let's just say f of x was, do you guys want to pick something or should I just make up something? Pick something, square root of, maybe it's the one that we were just doing, similar to that one, 2x take away 5. Doesn't matter. F of x equals square root of 2x minus 5. Okay, if I've got to shift left 3 units, what changes? What happens when you're shifting left 3 units to your whole function here? Yeah, isn't x going to be replaced for?
Oh, wait, what? No.
X gets replaced for x plus 3. That means shift it to the left 3. So it'll become this. Yes or no? 100%? Okay, so I'm going to expand. 2x, 6 take away 5 is 1. 2x plus 1. All good so far? So even though, you know, it shifted to the left 3, you can't see that. To you, it looks like it's a plus 1, but that's not how you do it. You just replace your x for x plus 3. That's shifted left 3 units. Okay, vertical dilation. Again, what does that do? Change the whole y value by the same scale factor. So the whole y value is all of this. So that would be, I'm just going to call it A, so you understand that was A. Yep. B, vertical dilation. That just means times the whole thing by the second transformation. Last one. Then there's a horizontal dilation of 3. What does that do? Replace your x for, let's see if you guys can say it right. You're going to replace your x for what in a horizontal dilation of 3?
A third.
Say it again. Is it specifically just a third? Is it just a third? But if I'm going to replace, do I just change x to a third, or do I change x to x on 3, like 1/3 of x? Yeah, like the x still has to be there. That's what I'm trying to say. Like x doesn't become a third. Up here we multiplied it by a third, whatever, but when you sub it in, the x is going to still be there. All right, that means the answer is this: 2x on 3 plus 1 would be C. Okay, you feel good now?
Yeah.
No, it's meant to be okay. It's just obviously I had mixed the two up and everything's going to go the opposite way. But now we're back. Yeah. Well, I'm going to blame Sabine. You guys can blame me.
Yes, I can blame you.
All right. One more. We'll just do a whole bunch of transformations, and if everyone's happy, that's it. F of x. This is the one I think you really want to know. So we're going to do it to this one. It's a circle. X plus 3 squared plus y minus 2 squared equals 9. Okay, let's shift down 3 and up, no, what? Right, and then up 3. Yay! Right 2. So shift down 3 and right 2. So no dilation, obviously, because there's no dilation in circles. It kind of is, but that's ellipses, which is out of your course. But anyways, shift down 3 and right 2. You know what most people write, yeah? They just go, shift it down 3. So instead of it being a plus 3, instead of it being minus 2 for y values, they're going to shift it down. Don't do that. Don't risk anything yet. Best way is draw your circle. So draw the circle. Here it is. X is negative 3. Y is positive 2. My radius is at 3. Thank you. I was hoping to trick someone. Yep. Always do. Boom. There's my circle. What are you going to do to this circle now? You're going to shift it down 3. So instead of it being at 2, it's at negative 1. So that's weird because a lot of people would have said shift it down 3 from negative 2. They're so negative 5. No, it's not like that. Right? So don't do that. Just take your time and draw it. There it is. It's at negative 1. And then go to the right 2 units. Also negative 1. So specifically there. X is negative 1, Y is negative 1. That's your new center. Will your radius change? Of course not. There's that, there's that, there's that, there's that. And then they'll just say, write the new equation. So the new equation is x plus 1 squared plus y plus 1 squared equals 9. Easy? Yeah, I agree. One more, maybe with a dilation. Now they had that as a little bit of a break. And then I'd like to move on. Y equals. Any functions that you can think of that you have seen or you want me to use? I guess let's do it with a trig. Actually, yeah, let's just do a trig. Like it doesn't matter. because you're just replacing x's and y's and stuff, right? So it's not about what, I can give you a log, I can give you an exponential, it shouldn't matter. So let's go with sine x, a simple sine x. Okay, what are we going to do to this sine x? Go, give me 1, 2, 3, and 4. You guys can pick it, so then it's fair. 1, pick, what do you want? Up to you, any word that you know. Sorry?
What? 25?
Add where, up, down, left, right? Up, so up by 5. Go, Fiona, tell us what you want to do. Left by 3. Yeah, let's do it. Which one? Horizontal or vertical? Horizontal dilation, oops, of 6. And then, I guess to finish it off, I'll do a vertical dilation of -1. We'll see what that does. Everyone's happy? Let's start. Just so we don't get confused, or maybe I don't get confused, horizontal dilation. Horizontal, we're going to go with f of a of x. Vertical, it's attached to the outside. This one, times by 1 on a. Maybe that's something you would write in your exam, so you don't get confused. I don't know. All right, let's go. Shift it up 5. 1. Y equals 2. Y equals 3. Y equals horizontal dilation. That means change your x to a 1 on a. So that means instead of it being x plus 3, no, I'm wrong. Instead of it being an x, it becomes a x on 6. I was going to say the whole thing's on 6. That's wrong. It's sine x on 6 plus 3 plus 5. Last one, 4y equals a vertical dilation. Anyone want to take a guess at the final answer? Do you want to say the whole thing, Eden, quickly? Yeah, you're going to remember that's attached to the whole thing. So it's actually -1. There you go. Happy? We're done? Done. That's your trig transformations as well.